Good morning, children. Welcome to your chemistry online class. We are going to discuss about the chapter thermodynamics. Last class we have discussed about the relation between Cp and Cv and how to measure delta H, delta U and all. Today we are going to discuss about the standard terms. Standard enthalpy of reactions. We know the enthalpy, that heat produced of the reaction, depends on the conditions. Maybe constant pressure, a volume. We are applying some conditions. Maybe one of pressure or volume will be constant. Certain things we will consider. So it is necessary that we must specify some standard conditions. So the standard enthalpy of reaction is the enthalpy change of reaction is the enthalpy change for a reaction. It is either enthalpy change of a reaction or enthalpy change for a reaction when all the participating substances are in their standard states. So the standard state of a substance at a specified temperature is its pure form at 1 bar. So we are considering a standard condition of pressure as in 1 bar. For example, the standard state of liquid ethanol at 298 Kelvin is pure liquid ethanol at 1 bar. This is the standard condition. So if carry out some reaction, we will take some standard condition. So at 1 bar, if you take a pure liquid of ethanol, its temperature will be 298 Kelvin. Similarly, standard state of a solid iron at 500 Kelvin is pure iron at 1 bar. So, if you take iron, if it is in 1 bar and 500 Kelvin, we can say that the iron is in pure state. Similarly, if we are taking ethanol at pressure 1 bar at 298 Kelvin, we can say that the ethanol is in standard state or its pure state. That is known as its standard state. We know if one substance changes from one state to other state, that is either solid to liquid, liquid to gas, there will be some enthalpy changes. Certainly there will be enthalpy changes. We will see what will be the enthalpy changes in these things. So phase transformation also involve energy changes. So for performing a reaction, heat for doing an action. For example, ice melting into water. So we should provide, or it should be, there should be heat. There should be a requirement of heat to phase change. For example, we know water, ice is in solid state, is converted to liquid. The solid is converted to liquid, we can call the process fusion. So the enthalpy change or heat change is 6 kilojoule per mole. So while solid is converted to liquid, the heat changes is, or heat required is 6 kilojoule per mole. So the enthalpy change that accompanies melting of 1 mole of solid substance in standard state is called standard enthalpy of fusion or molar enthalpy of fusion. That is the enthalpy change. We know there is an enthalpy change. For what? Melting of 1 mole of solid substance. So if it is in standard state, we can call it as standard enthalpy fusion or molar enthalpy of fusion. It is denoted by the letter delta H fuse. So it is for the fusion process. If the amount of heat required to vaporize 1 mole of liquid at constant temperature and under pressure 1 bar, we know standard pressure is 1 bar, is called standard enthalpy of vaporization. So the amount of heat required to vaporize 1 mole of liquid at constant temperature and under standard pressure, that is known as standard enthalpy of vaporization or Molar enthalpy of vaporization, it is denoted by the letter delta H wave. So, if solid converted to gas sublimation process, what we can say, standard enthalpy of sublimation is the change in enthalpy when 1 mole of solid substance sublimes at a constant temperature and under standard pressure. That's one part, denoted by delta H sub. So these are the terms. Next one is standard enthalpy of formation. The standard enthalpy change for the formation of 1 mole of a compound from its element in their most stable states of aggregation is called standard molar enthalpy of formation. That is, if 1 mole of compound is performing, that is standard condition, from its elements in their most stable states called standard molar enthalpy of formation. It is the enthalpy change accompanying the formation of 1 mole of the compound from its constituent elements in their most stable state. That is known as standard reference state. It is denoted by the letter delta FH. For example, the enthalpy of formation of water and methane water is minus 285.8 kilojoule mole inverse. We'll see thermochemical equations. So the thermochemical equations are the equations which is a balanced chemical equation together with the value of enthalpy of reaction. This is known as thermochemical equation. What are things we have to keep in mind? The coefficients should be balanced after the reaction, and we know if we balance the reactant side and product side, the number of moles should be equal. Then only we can say an equation is balanced. And the value of delta, the enthalpy of reaction, refers to the number of moles of substance specified by an equation. Standard enthalpy change will have units as kilojoule per mole. We'll see Hess's law of constant heat summation. The very important law. The enthalpy is the state function, and therefore the change in enthalpy is independent of path. If it's a state function, we know it is independent of path between the initial and final state. So it is independent of the path. It is a state function, so it is only depending upon the state, not the path. It's not depend the final state and initial state. So the enthalpy change for a reaction is the same whether it is a step or series stage. Whether it occurs in one step or a series of sequence of steps. We should consider these things. No need to consider the path of the reaction. If it is occurs in one step or several steps, the enthalpy of formation remains same. If reaction takes place in a several step, then its standard reaction enthalpy is the sum of the standard enthalpies of the all steps. That is the intermediate reactions into which the overall reaction. In general, if enthalpy of an overall reaction, that is A, is the reactant which converted to product, that is B, along one route is delta RH, that we can define is delta RH, delta RH1, delta RH2. If how many steps were there, that much we have to calculate. So these are representing the enthalpies of reaction during the same product B. If there is another route, then delta RH is equal to delta RH1 plus delta RH2, it will go on. So it may occur in several steps. Directly A will give B, B will give C, C will give D, and D we can give A back. Next one is standard enthalpy of combustion. This combustion, we know in the combustion reaction heat is produced. Such reaction is known as combustion. So if heat produced or heat evolved, such reactions we can call it as exothermic in nature. Heat evolving reactions are exothermic in nature. So the standard enthalpy of combustion is defined as the enthalpy change. It is an enthalpy change per mole of a substance when it undergoes combustion and all the reactants and products being in the standard state. So we can generally define it as it is the enthalpy change per mole of a substance when it undergoes combustion and all the reactants and products be in the standard state. If the products or reactants in the standard state, 1 mole of product is formed from its reaction, or 1 mole of product or 1 mole of product is produced by the combustion of reactants. It is represented by the letter delta CH. The next one is standard enthalpy of atomization. So it is this enthalpy change in the process of breaking bond is called standard enthalpy of atomization. It is the amount of heat or enthalpy heat change occurs in while breaking bond. That is, it is the enthalpy change on breaking 1 mole of bonds completely to obtain atoms in the gas phase. So here 1 mole, that is the standard condition. 1 mole of bonds completely breaking and it gives its atoms in the gas phase. It is represented as delta H. Atomization H. We'll see what is bond enthalpy. It is noted by the letter delta bond H. It is 2 types, bond dissociation enthalpy and mean bond enthalpy. For diatomic molecules, the enthalpy change involved in this is bond dissociation. That is, diatomic molecule, this bond will dissociate, break. So it is the change in the enthalpy when 1 mole of covalent bond of gaseous covalent compound is broken to form its product in the gas phase. So the reactant and product should be in the gaseous state. So this bond will break and it will change into 2 products. If H2 break, we'll get 2 hydrogen atoms. From hydrogen molecule, we'll get hydrogen atom. This is bond dissociation enthalpy. For polyatomic molecules, we are using mean bond enthalpy. For diatomic, we are using bond dissociation enthalpy. It is very important quantities. That is, here we can see in polyatomic molecules, the old bonds break and it form new bonds. So bond breaking is occurring here and bond forming also occurring here. So it's important. So it generally we can give a formula that sigma bond enthalpy of reactants minus sigma bond enthalpies of products. So the net enthalpy of a reaction is the amount of energy required to break all the bonds in the reactant molecules minus the amount of energy required to break all the bonds in the product molecules. This is only possible in the gaseous state. From the enthalpy of solution we will discuss in next class. Thank you.